Hey, hi everyone. So in this video, we'll talk about conditional branching in AI agent workflow. So many times we have like specialized agents in our workflow, and based on certain conditions, we want to either send it to agent A or agent B so that they can process in their own specialized way. So we'll see something similar to this in the workflow. We'll also see loops later on in this tutorial as well. So let's start off this problem. We have let's say this state, and here the input will be property URL. So it's like a listing URL, a property listing URL. And let's say we want to generate a blog out of this URL. Let's say we have two different agents, one which can generate blogs for rental properties and another agent which will generate blogs for the properties that are being sold, not rented out. So based on these property URLs, if they belong to the rent category, they'll go to the rent blog generation agent, or if they are selling the property, then it will go to the sell agent. So this is how we'll define the state then. Basically, input is property URL, and is rent will be true or false will be set based on a condition. We'll discuss more on this, but it's basically a flag saying that is it a rental listing property or not, or is it being sold. And then we have a final output state, which is just blog, which is the generated blog. We don't really need two flags here, but for simplicity and all, I've kept it two, but they are mutually exclusive. So let's start building this agent, which will have like this conditioned branching, and it will either go to this agent or that agent. So let me define the nodes here. The very first node is this node makes the decision if it is a sell or a rent property. So it takes in the property URL, and it will actually process the URL, scrape the URL, get the text, and maybe pass it through an LLM to say if it's a rental property or a sell property. But for now, we have kept it very simple. If the word sell exists in the URL, we are considering it as a sell. Otherwise, we are considering it as a rent property. So we are just setting these flags accordingly, and we are updating the state. This is very simple, but it will have like some complex logic here to actually determine if the URL is a rent listing or a sell listing. And then we have a specialized sell blog generator. So if it's a sell category, it will take the URL and generate the blog for that and return this blog. And then we have, in a similar way, we have a rent blog generator. Of course, the logic will be much more complex here as well for both of these agents, but you can see like these are specialized agents. So the workflow, we'll either send it to this agent or this agent depending on what URL we get. Let me also define the graph here. So we are just adding these three nodes in the graph, and we are adding three edges for now. Start will go to either sell or rent, and then once blog is generated, either rent blog is generated or sell blog is generated, we'll end the workflow. And now we'll only have to define one single edge, which is from this node to either one of these. And for that, we'll add a conditional edge. The way to add this conditional edge is like this. It will start from this sell or rent property. This is the node that it will start from. And this is the router function that we'll define in a moment that will decide where it will go. So if this router function returns rent as a string, it will go to this node. If it returns sell as a string, then it will go to this node, which is basically sell block generator. So let's define this router function. It's hopefully simple now that you know how to use the conditional edge. Let me just define this above here. So yeah, this is the router function, and it will also take in state, and it will read from the state basically. So whatever the previous node had set, it will just read from that state, and it will return whatever route that we want to go in our workflow. So once this is defined, we can set up the graph again. Let's run it. Yeah, so the graph is compiled. Let's print the graph and see. Great. So we see these dotted lines here. So from this node, if it is a rent, it will go to rent block generator and end. If it is a sell, it will go to this sell block generator and end. So either this node or this node will be executed based on the input that we get. That's how this graph works. So very quickly, let's run an example. I'll just give like one URL saying rentyourplace.com. It just contains the word rent, and that's our simple logic which it is based upon. So if it contains sell, it will set sell, otherwise it's rent. So I'm not putting sell here, so it should hopefully consider it as a rent. So rent is taken by default if there is no sell in this URL. So it's like the rent agent had generated the blog. If you see the blog here, generated sell blog based on URL, and then generated rent blog based on URL. that is the output that we get. The blog was generated by the rent agent here and not the sell agent. So similarly, if you have something like sellyourplace.com, it'll generate like a sell blog rather than a rent blog. So hopefully this is clear, like a very simple workflow logic. But if you want to ever have conditions in your workflow, this is how you can do it. Now we can tweak this and use these conditions to our advantage as well. We can have like an evaluator agent, and if the evaluator agent does not like it, it can also send it back to one of these blog generators to generate a better blog with its comments incorporated. So that is also something that we can do because we know how to use these conditional edges now. So let's go ahead and build something of that sort as well. So we'll keep the state almost the same, but there is just one more attribute that we have added in our state called evaluator comments. So this will be added by the evaluator agent, as you might have guessed. So to simulate this evaluator comments, I'm going to use like random number generator. I'll just generate a random number as either 0 or 1, and if it is 1, then we'll imply that hey, the evaluation failed and it should go back to one of the blogs and fix it. Or if the number generated was 0, then we don't need any evaluation, we are good, and we'll end the state. So let's define the nodes. It's almost the similar, but minor things we have added here. So this sell or rent property node remains the same. It'll just see if the word sell is present in the URL, but it can have like a complex logic. In the sell block generator, we have just incorporated this evaluator comments now. We will try to get this evaluator comments if they are set already in the state. And if the evaluator comments are already present, then we'll generate the blog considering evaluator comments as well. Basically, we'll rewrite the blog. Else we'll just write the blog from scratch using this URL. In fact, let me just put and evaluator comments here. So yeah, we'll regenerate this blog. If we already have evaluator comments, that means we had already generated a blog and evaluator said it's not great, and it will add its own comments. So let's incorporate that and generate another blog. This is what this means. Else it will generate the blog from scratch. So similar thing happens with rent as well. Let me add this part here as well. Great. So we'll regenerate the rent blog here or generate the rent blog from scratch. And then we have this bot evaluator that I explained earlier. So it will read the blog and it will either pass or fail. So even here there will be some logic, maybe an LLM call, or based on some criteria you can either pass or fail the evaluation of this blog. This is another way of saying like LLM as a judge if you are using prompts to evaluate. But we are not using LLMs or anything. We are just generating a random number here, which is the greatest way possible to evaluate any blog. So if the number generated is 1, then we'll add this comment, or else we'll keep the comment empty. That's all what we are going to do. So let's set up all these nodes and let's build the graph. Let me just paste the code for the graph. We have added 4 nodes here, which includes bot evaluator now. And then there are 2 conditional edges here. I'll explain the conditional edges. So first conditional edge is simple, straightforward. The same router, if it returns rent, it'll go to the rent block generator. Sell will go to sell block generator. And now we have this second conditional edge, which will go from blog evaluator to either end. It can also end the workflow if the evaluation is passed, or it should go to the rent block generator if the rent block generator had messed up and the evaluation failed for it, or it can go to sell block generator as well. So let's define this router functions as well. Let me just paste the router functions up here. So this router is the exact same. It just reads the state and returns rent or sell. And we have a new router here based on evaluator. So this evaluator router can return 3 states, 3 routes. It can either go to rent, sell, or it can also go to end. So if there are no evaluator comments, that means we are good and we'll end the workflow. That means our blog is the final one and we don't need rewriting the blog. Else, if the state is rent, then send it back to the rent block generator. If the state is sell, send it back to the sell block generator. So let's define the router. Let's run the graph. Let's print the graph and see. Oh, looks very complex enough, I guess. But it's very simple. It goes through this decision maker, where it either sends it to sell block generator or end block generator. And both of these will eventually lead to this blog evaluator. So finally we'll reach here. And this blog evaluator is the final decision maker. It will send it back to the rent block generator, cell block generator, or it can end the workflow. So this is the task that if block evaluator will do. So hopefully this is still very simple workflow. Not very, it might look complex, but it's not. So let's run this graph and see what happens. Okay, great. So it went inside the cell block generator, and evaluator comments are empty, and it generated the cell block. I mean, the evaluator in this case said we are good to go. That's why it just ended. Let me just rerun it again. Okay, now there is some rewriting happening. So first of all, it's a cell block because cell word is present in the URL, or rent word is not present in the URL. So it went to the cell block generator, it wrote the block. The evaluator thought it was not good and sent it back to the cell block generator, and then it rewrote the block. And then again it came to this blog evaluator, and again it said, hey, this is not good. So it went back again, and in this case evaluator said like evaluator comments are empty. That means it said good to go, and that's how it ended. So this is the final state that we are seeing. So evaluator comments were updated, but we are not able to see it. That's the only thing that is happening here. If you want, we can print the evaluator comments as well. So let's just print. Yeah, I'm just printing the evaluator comments here. So if it is empty, we'll know that the block passed. So here we got evaluator results. Why is it so messy? Fix everything. It went again. If you see here, regenerated cell block based on this URL, and this is the comment that we had sent as evaluator comment here. So it regenerated the block again, and similarly you can also test it for rent. So since now a rent is present in the URL, it will go to the rent block. So if you can see here, rent block is generated, but evaluator said, hey, it's messy. Then it again went to the rent block generator agent, and then rent block generator agent regenerated this whole block based on these comments. These can be like legit nodes using LLMs, where comments are legit, so that the block generator knows what all things to be updated in the blog as well. And this is how you can make like a good enough complex workflow where you know that you will get a decent blog because of this evaluator or LLM as a judge, whatever you call it. So yeah, that's all for now. Thanks for watching, guys. Bye.